Okay, so this week we're going to add on to what we talked about last week. So last week we had the Bohr model and then into quantum mechanics. And I had asked a question about what the Bohr model got right. And what the Bohr model got right was that there was quantized energy levels, and we still use that. What he didn't account for is the electron-electron interactions. So that's why it worked for hydrogen, so it worked for the element that has one electron in it, because it didn't have any electron-electron interactions. It was just one electron that was there. But when they got up to more than one electron, this is what happened. So when you have an atom, you have the protons and the neutrons in the nucleus. So the protons are positive, neutrons neutral. So these electrons that are out here, there's a reason why they don't crash into the nucleus, but that's a whole nother angular momentum conversation. But just think about positives and negatives are going to be attracting each other, which is pulling the electrons in closer to the nucleus. But this other effect is electrons are both negative. So there's going to be, and I put this little orange arrow, there's going to be repulsion between the electrons. So it's the inner electrons, the electrons that are closer to the nucleus and lower in energy, that are repelling the outer electrons that are out from these inner electrons, or the core electrons. So down here, other than the picture, and there's a better picture in the book, it has the inner shell, N. So remember, shell is the N in the quantum numbers. They shield, the inner shell electrons shield the electrons that are further away from that positive pull of the nucleus. So the nucleus is pulling. So the nucleus actually has a charge to it, right? And it depends on the number of protons, the magnitude of the charge. So Z is representing the actual charge of the nucleus. So when you just have this one electron, it's completely feeling the positive pull of the nucleus. But if you have multiple electrons, they're going to repel each other. And what each one of these electrons feels is this effective nuclear charge, which is the amount of charge from the pull or attraction of the positive nucleus, but it's also getting pushed out a little bit and feeling less of a charge because these electrons are repelling. So we say these inner electrons are in fact shielding the outer electrons, so it doesn't feel the entire nuclear charge from the nucleus with the protons in it. So what's different between Z and Z effective? So Z effective is what the electrons actually feel as the pull of the nucleus. So there's an equation. We're not going to plug in any numbers into these. That kind of give like rough estimates based on the number of protons and electrons and what shell they're in. But all I want you to know is that effective nuclear charge, which is what the electrons are subjected to based on their location, is the full nuclear charge from the nucleus minus the shielding from the inner electrons. So when we talk about trends, which is going to be like atomic radii and ionization energy, it's going to come back to this picture and this representation of what's happening in the atom.